certain type of customers sort of say, well, you're treating us like guinea pigs, right? And it's true. But it's the state of the industry we're in. It's, yes, we're all guinea pigs to a certain degree. Having 3 or 4 years, I mean, in a very early industry, as far as experience, means that you're actually picking up a lot of issues. I thought to myself, and I go, I got kids, I'm going to have grandchildren. And one day they're going to say, okay, were you part of the problem or were you part of the solution? We didn't start Evo Power on the basis that I was his employee and he was the boss. It's not just, someone saying, no, we're just doing it my way and that's it. That's a sign of a really good boss, actually. That collective experience is really, really important.
Just finished sitting down with Richard Smaldino from Evo Power. Now, this man is an engineer's engineer. We talked about such diverse subjects, including ultra long range target shooting, grid stability, grid following, grid forming, Evo Power, what they're actually doing in this battery space, and lots of nitty-gritty subjects, including mentors and what it takes to be a good engineer, especially in the renewable energy industry. This is one of my favorites. It definitely should be one of yours. So sit yourself down, strap yourself in, and prepare yourself for a very interesting podcast. I suppose I'd like to start off with a question I ask all my guests. Is it being a good engineer, is that nature or nurture?
Okay, I would say 80% natural, nature, and then the other 20% is the nurturing that you get. When I was a young lad, if anything broke in the house, and this is back in the days when everything was really simple too, I would just take it apart. And that was like from 8 years old to sort of, and it just sort of, for me, it was just a natural thing of wanting to understand what was inside things, right? And then for me, it was just such a natural journey to, to go into university. And as an engineer, did really well at the STEM subjects back then in HSC, and not so well in English. As any good engineer should do, fail their first year because of partying and all that sort of stuff.
Nice one, Richard. Now I see. Yeah, good.
And then smash the next, second to 4.5 years, and get a second degree, second class honours, sort of.
Well, let's jump back a bit. So we've gone from like you're a young child, and look, honestly, Richard, every engineer I've spoken to, they all have a similar thing about wanting to know how things work and taking them apart and not necessarily putting them back together again correctly, but it's more that process. They really wanted to know, and that's who they were. It wasn't learned. It's something innate, and that's why when you say an 80-20, I'm inclined to believe 80-20. One engineer, a friend of mine, Gil Rhodes, came on. He said, when you study engineering, it doesn't teach you to be an engineer. It teaches you how to think in a methodical manner, which tends to align already with the kind of personality you are with most engineers. Would you see that as being a...
Yeah, that's absolutely a really good assessment of it. I think especially in those early years, it was really sort of just having that sort of mind. And then, yes, of course, then getting sort of into, back then we used to do this work on our own cars, right? So I was sort of, turbocharging, playing with ECUs, all that sort of stuff, as well. Got into a little bit of racing, got into the Subaru STIs, joint clubs and that sort of stuff. So I think...
They had a problem with the CV joint, didn't they?
Oh, no, look, I didn't break any of those.
Oh, okay.
But I was doing a lot of sort of, going on racing circuits and all that sort of stuff with it. So hotting everything up to the maximum, and it was so much fun.
So that's like a mechanical engineering kind of thing, isn't it?
Well, it was interesting because it was mechanical. So, put in, actually installing your own components, whether it was the muffler or whether it was the cold air intake or all these sort of things. But there was it was the early days of those ECU type cars, so the engine control units, right? And that's, that all related back to, fuel air ratios and control of and injectors and all that sort of stuff. So it was actually understanding how all those sort of related to performance at all the different rev ranges, at all the load points and all that sort of stuff. So it was actually, again, it's just when I get into something, I just get into it. So
you go deep
at a deep technical level.
That's good.
To the point like, some guys in America cracked the code of the Subaru ECU. And so we were able to get the maps from it and using other software, change the maps and then reflash the ROMs and then have a go at how, and that was the original factory ECU, not aftermarket. And so I was doing this for a couple of years and actually went with the technical director at Subaru. Showed him how to actually do it.
Wow, really?
Yeah, so back in the day, yeah. So, and it's that natural thing, and it's just like some of the hobbies I take on. I just always go to the nth degree. I'm also into long range shooting, for example, at the moment.
What do you mean long range?
900 meter sort of stuff. Yeah.
That's
and
sniper kind of stuff,
yeah,
isn't it? Wow.
and shooting sort of in groups of 2 or 3 inches sort of thing, so in 10 shots. So I got into that a couple of years ago. What I could sort of see was, Valley, what happens to my brain when it's idle? I drive myself nuts, right?
Yeah, right.
So I realized that I needed to take on a hobby that was ultra sort of technical, and the long range shooting, the amount of variables that we need to take control of is absolutely incredible, and that's from making your own bullets, setting up your rifle, and then reading the wind and
air conditioners, humidity,
absolutely all that sort of stuff. So that's so what I've realized was like, oh my God, I'm nearly 60 years old. I need to keep myself busy as I head towards those retirement years.
Mentally busy, yeah.
Exactly, yeah. Otherwise, I will drive myself nuts. So that's what I do at the moment, and decided that I want to get really good at it, and just I got right into it, and I was doing competitions last year and coming in the top third, and
wow.
Over Christmas, went for a couple of open prize meets comps, and came third in 2 events, 2 different sort of meets. So it's this year I'm going to try out for some state and national comps and see how we go.
What I'm going to guess that the caliber would be like 3008 or something like this, or what?
No, it's a 6.5 Creemore. So it's a very flat shooting sort of. It's a round, a load or cartridge or bullet that's renowned for sort of accurate flat shooting, long range. So yeah.
So you like precision?
Yes, it's all about precision. Yeah.
Can I? In your younger day, did you play much snooker or pool or billiards?
No, I enjoyed it.
Yeah,
but
right.
no, not much. No,
because that to me is a bit of a precision thing. The ability to repeat time and time again. Would it be a fair assessment that you try to get to the essence of something fairly quickly to understand it?
Very quickly. Yeah. So it's even with the shooting. I mean, just from a point of view of, I just got into it into a very detailed way, trying to understand the mechanics of it, and just realizing what affected accuracy and precision and what didn't, and then developing my own systems to try to sort of hone in so I could get the smallest groups possible. So. And I've done it in a surprisingly short amount of time, in 1 year.
That doesn't surprise me. Wow.
So yeah.
So are you at the point with the shooting where, and I think I could probably relate this to some other things I'll ask you, where you go, I've read everything, I sort of gone to the point where I'm a little bit ahead of that.
Yes.
You know? Yeah.
So that's where I'm at now, where I'm actually sort of comfortable about talking to people about their problems, if you like. You know what I mean? Because you felt like, I feel like, no, I understand that part of it now, and there's multiple parts I don't understand still. Oh, I'm getting, I need to understand a lot more. Reading the wind is just an incredible thing, right? But especially from the reloading process, I think that's, there's a measure of if you're able in your reloading process, for example, and have a 5 or 10 shot group, and the standard deviation is only 5 feet per second or so, that's like that's the ultimate goal, and that's where I'm at the moment. So yeah.
So you'd have to make when it came to actually putting the excuse the simplistic approach of putting the potassium nitrate or whatever it is into little capsules. You'd have to have incredibly accurate scales, but at the same time, you'd have to maintain, I think, the humidity and the temperature of the room in which you're doing it to get the accuracy. Is that correct?
I don't worry about the humidity and temperature, but it is a factor. But it's so much. There's only so much you can control, and it's like that's getting down to the 0.001 percentiles.
Marginal diminishing returns.
Exactly right. So, but I do have a scale that measures to the 1,000th of a gram.
You'd have to have it in a cabinet, wouldn't you?
It's got a little sort of cabinet. Wow. Yeah. So, and because that's a thing, because what you want to take out is all the variables, right? And if you're shooting at like a crosshair or something, you want the actual only the wind to affect it. So you should see all your bullets along one line, because the speed hasn't changed.
The trajectory hasn't changed. Well, okay.
Yeah. So because
the wind doesn't blow down, does it?
Well, the wind blows everywhere because then they're based on land as well. So you've got like divots that'll go in and then push the bullets up or down. And
at least you don't have to take into consideration the curvature of the Earth over 900 meters.
Maybe over 2 kilometers.
And people can shoot.
Yeah, there's actually it's called ultra long range, and so they go out to there's 1 mile and 2 mile, 3.2 kilometers.
Oh my gosh. I didn't realise they could shoot that far.
Yeah, no, it's crazy. It's that sort of stuff is you'd need the big calibers and really heavy loads and that sort of stuff. But yeah,
the gun that you use must be expensive.
No, I actually
don't tell me you made it yourself.
No, I actually shoot in a class. It's called hunter class or sporter class, more appropriately now, and it's something that you can buy off the shelf. And it's got its standards that you have to operate in.
Right.
But I found that there's there's a lot of different type of class of long range shooting. I feel like we're talking a lot about shooting.
I'm interested from the perspective of the precision and the attention to detail, which will lead me on to other. You know what I mean?
Yeah. But there's other classes which sort of have like very heavy guns, basically almost clamped in, on both sides.
Right.
And so you fire it always goes back, and you can sort of see the crosshairs. So in sporter class, it's only of the bipod.
Right.
So you have to and your scope, and usually we use larger barrels because the thickness of the barrel is important. Okay.
So they're quite a heavy gun.
Yes, it's a heavier gun that normally people wouldn't take hunting, but it's meant for if you fire in quite a few shots. Because imagine if you're hunting, you fire 2 shots, and that's about it. But we're firing 10, 12 shots, maybe up to 17 shots in a row.
Heat dissipation.
Yeah. So then what happens with heat? The barrel moves and warps, and you've got to start chasing that as well too much if you've got a smaller barrel.
So you'd be thicker walled. And
exactly.
That makes sense.
So and what I liked about that class was the purity of like you have to position your body absolutely properly. Your everything that you do from your trigger pull and everything has an effect of how much. If you can imagine over 900 meters, and you just sort of move
a hair.
That's out nearly half a meter. Yes. So your trigger pull is becoming important. Your natural body frequency becomes sort of, important.
That's interesting.
Yeah. So you need to be naturally calm in that sort of environment because your body positioning, your trigger pulls, everything is in effect. And we talked about the reloading and to what extent you go there. But I found this class very, very pure, and so that's why I started in this class, and I'll probably progress to other classes down the track. But I thought this class would give me my best way to learn how to shoot long range properly. So
it sounds like when you're actually about to shoot, you're in the flow state. You're in a deep focus state.
Absolutely, yeah.
100% concentration. Yeah, right. Okay, that's really interesting. Oh, let's jump back a little bit.
Okay.
So as a child, breaking things apart, wanting to work out how they work, and then you grew up. You're of Italian background.
Yeah.
Northern, southern.
Southern. So my grandparents, my parents, and uncles, and that sort of stuff. They came out from Italy after the war, in the late 50s, sort of thing. So we grew up. My first language was Italian. Up to 5 years old, I only knew Italian. I didn't know any English. Born in Australia, so then like the problem was that there was we'd form our own communities as you do, and so I'd get together on the weekends with my cousins who also only spoke Italian. It was just like it was weird, living in another country and you're born here.
But it's a natural thing, though, isn't it? That we flock together to what we know.
Well, it was interesting times. Let's just sort of say, and we had to form communities because there was still a sentiment there about after the war, right? Okay, so we. We had to sort of form those communities because it wasn't the same Australia as it is now. Because I talked to if you look at our workforce at Evo, for example, it's so multicultural. And I asked these guys, how do you feel about Australia? Do you feel like it's racist or is it an accepting environment and that sort of stuff? And they sort of say, this is incredible here. We've got more racism amongst ourselves, So, but back then it was a lot different, and I think that's why. They formed their own communities. It was but because of that, I found that it was such a great childhood because we had a community. We'd sort of, it was just some sort of deep comfort about having that structure, which, when I talk to about my kids, they go, oh, I wish we had that. You know what I mean? Yeah.
Yeah.
It's because as we've gone into, first generation here, second generation, we've just acclimatized to the way it is in Australia. I think in the end of the day, that community is really, really important.
So you made, did the family get to make salami, do the tomatoes, the whole bit?
The whole lot, yeah. And, it's like, even now when, I look at a barista and I look at them in the face and I make a judgment whether they can make coffee or not. It's just an Italian thing, right? It's just, so it's, we are so brought up on that sort of culture of how something should taste, or and freshness and of the goods that you eat, and all those sort of things come together. And there's never, it's not like the castle where Oh, it's what you've done with it. No,
right.
There's an actual process where
Yes,
your mum cooks the food and the dad has to judge it. And there is a feedback loop all the time. And I think that feedback loop was really, really important to keep on improving.
And those
Funny
same
enough,
processes and procedures you're talking about are applicable to engineering, aren't they?
Yes, correct. Yeah.
It's funny, my dad came out in 56, so around about the same time as probably your parents, and from Serbia. And my mum's Anglo, but she speaks Serbian as well. So I'm half. But I remember very clearly that we got together with family and did certain things, similar. But the Anglo people at school, what do you do? What's this wog shit you're doing?
Yeah,
and that was but they didn't understand. But as they got older, they realised, wow, they were the ones missing out really on that community and doing things in a group. Whatever it is, whether it's cooking, whether it's gardening, whether it's helping someone, and because it's a pretty wonderful thing.
Yeah, and we were, I was building bungalows at 10. Totally unregulated, totally.
Oh no, with the asbestos sheet too, probably. Yeah,
yes, exactly.
Wow.
Yeah, that was what you did. You got together with your uncles and you helped each other out, And that sense of community, as I said, was so important to my upbringing. And I think being involved in all those activities was also probably part of why I became an engineer. Just building stuff and doing all those sort of things,
Did you have any mentors, like when you were young, like even in high school or?
Yeah, look, not really. I was a very introspective, not introvert, I would sort of say. I was a very introspective kid, very observant of people. And I think I'm glad I was. It's made me sort of that observing people at that young age and realizing someone's saying this but they actually mean this, and someone's looking this way which is not matching up with what they're saying. It's made me really sort of able to understand people.
Wow.
And so in my little battles, whether they be commercial and that sort of stuff, it's been and look, I say this because we're all built a little bit differently, and I've brought in people in my teams that might have certain things that the labels that people have put on them, and they make fantastic, for example, project managers because of that. It's their superpower. So I sort of, I bring up my thing about that introspective thing is because, we sort of always worry about our kids and, they're a certain way and that sort of stuff. And I think we need to sort of really realize is we're all different. Yeah, and we're all essentially on the spectrum, especially engineers are all on the spectrum to a certain degree.
I reckon you might be right. No, in the nicest possible way. I mean, and the thing is, I mean, we could talk about the people being diagnosed or categorised as potentially a way for the medical establishment to make more money. But that's I'd have to take my Greenwood hat off and probably have another conversation, because I really think, I grew up and probably around the same era, and there's always these kids who are hyperactive in the class, more hyperactive than anyone else, but they were that's how they were. But now they would be labelled as ADHD or whatever the acronym is. But you need people who can think outside the norm to actually move forward and achieve these quantum leaps in whatever field they're involved in, because without them, nothing's going to happen. Yeah. That's what I reckon.
Einstein wasn't normal, bro.
He didn't speak till he was 5 years old. Or 7. I think it was 7, yeah. Exactly.
Exactly. So you've hit a great point there, and that is that there's those little differences that creates brilliance. There's or creates new inventions or creates ideas.
Exactly.
It's those little nuances in people, and I think the takeaway, I think, is from my point when I'm mentoring is to realize, what little quirks do people have, and how do we use that to your advantage, and realize that the quirks that you were picked on is actually now what you should appreciate.
And it's also the ability to understand what people are capable of, because one common thing I've seen throughout my years on this earth is people getting employed for a certain role, and this is a nature-nurture thing, let's say as a project manager, and they might be decent people, they might be very intelligent, but they are shit at managing people and having a process and procedure-driven thing. They're crap. They're good at go off and do your own thing, but don't, you're crap at trying to organise other people.
Yeah.
So I think that's a mistake you see in a lot of business. People go, oh no, we'll take them to a weekend away where we can learn how to bond and all become the best project managers. Well, no, there's certain people who will never be good project managers. Yeah. There's certain people who are not good at selling. There's certain people who are not good at public speaking, no matter what you teach them.
Yes, yeah.
You've got to find out and be honest about what you are basically good at.
Yeah, and I think it's a really good point what you just said. Once you realise what you're sort of good at, I think also be very comfortable about it. Don't worry about that guy can speak better and he's the sales guy, right? What I actually feel a lot in the young engineers that we have at Evo and when I go out elsewhere is sometimes they actually, and we're talking about a problem, they've got an idea in their head but they won't verbalise it because they're sort of afraid, for example, of that's silly, or
or their English may not be the best.
Correct. Yeah, exactly. So. And, I've always encouraged people to sort of just speak up. And I've always said to people, there's no such thing as a dumb question. There's only dumb answers, right?
That's true.
Yeah. So I think, that's sort of really important what you sort of said, is people to be comfortable about who they are and what they do, and then sort of keep on working on that, verbalise, put your thoughts out there. You've got nothing to lose, you know what I mean? So, generally, we're in a group of people. So, look, if you look at it, Jamie and I started Evo Power, basically, right? Now, we didn't start Evo Power on the basis that I was his employee and he was the boss, because in the previous company we were with, I was the boss and he was my employee. So we sort of really had some great logic arguments. Jamie thought we'd go this way, I thought we'd go this way. And we broke down that logic until we decided, what, this makes the most sense, because there was elements of what he was saying and elements of what I was saying. And that's the way we move forward and actually make, good progress or things are less likely to go wrong, is by using those combined experiences, not just, someone saying, no, we're just doing it my way and that's it. And that's a sign of a really good boss, actually. When he sits down and sort of says, tell me what the problem is, and gets 6 different opinions. And then the boss part of it is, formulating the best logic out of those 6 opinions and coming out with okay, what does everyone think about this, right? Because that collective experience is really, really important, and one of the things I do is a lot of troubleshooting at work, because 40 years of engineering, railway, touching things, making things, bending things, blowing things up. So there's a lot of sort of that sort of troubleshooting skills come out of all of that, right? And unfortunately, a lot of young engineers nowadays, and especially in Australia, where we don't have much manufacturing.
Yeah, we certainly lost that.
They don't go through those that school of hard knocks, and it's quite interesting. Also, for example, like an electrical engineer is not allowed to work on electrical stuff in Australia. I mean, so. There's sort of little regulatory things like that. So I think, I suppose we went a bit off tangent, but I think, it was a good tangent to go on. But that's my sort of take on management and engineering management and making that sort of group decision sort of stuff.
I think a good boss too should also try to surround themselves with people at least as smart as they are, if not smarter.
Yeah.
And then the ability to collect that information. Now I know Jay. I used to work with him at CTEC for a short time until the renewable energy department went kaput. And he's a very level, like Hayden Fletcher. They're both very level people.
Yeah.
They don't talk before they think, and it seems that the best teams have a combination of people who are like this. That people who are absolutely crazy and people in between to get the most out of something.
Well, I'm constraining myself, but I'm that crazy type.
I know you are. I know, but also with that attention to detail as well, which is an amazing mixture, by the way. All right, so you've gone to uni. What did you, uni in Melbourne, was it?
Yeah, it was Swinburne. Yeah.
Swinney. And
it was a tech back then, but yeah.
And you did, and because you mentioned this off camera, which I'd never heard, manufacturing engineering, which is now called Mechatronics. Can you explain a bit what that actually entails?
Yeah, sure. So manufacturing engineering was all about not only how you would sort of set out a factory, but how you actually go about designing a machine, a lathe, for example, and all the gears and how they interact, all the mechanical forces, all that sort of stuff. And then that was mainly the mechanical side of it. And then the electrical side came in as well. So we had to do electronics. So how do you control your piece of machinery, through sensors, through PLCs, through sort of algorithms of control. And then back then, we had the first foray into computing, XTs and ATs.
Do you remember the little cards?
Yeah. So we got into Pascal and Fortran type
COBOL.
Programming and but it was very early days in the software side of things. Everything was more sensor based and hardwired logic. The PLCs were just coming in as well, and so we learnt ladder logic on those. So it was all about manufacturing process, manufacturing machines, and the mechanical and electrical side and software side of those sort of things. Yeah, so now Mechatronics is like it delves a little bit into the mechanical side, but it's mainly about the software.
Oh, okay, I didn't know that.
And electronic side of things. Yeah,
yeah, right.
Yeah, my daughter did mechatronics. So she's engineered.
This is the one with the Toyota Land Cruiser.
Yeah, that's right. We
You started to tell me that story, but I'll get you to expand on it later.
Yeah.
So this is a classic example of nature, isn't it?
Yes, correct.
Genetically, your daughter is obviously inherited, and I assume, I'm not sure if your partner's an engineer.
No, she's a teacher. Yeah.
Okay, so she's got brains too. My mum was a teacher. So your daughter's inherited that engineering or that love. Was she the kind of person that broke things apart when she was young as well?
No, that was a thing.
Oh boy, all right. But there goes my theory.
Yeah, but she was very good. She's smarter than me. She was very good at the STEM sort of subjects as a girl. She ended up doing a double degree at Monash, astrophysics and mechatronics.
She's smart. Yeah. Wow. She went right through
double degree. Yeah,
wow.
And she worked in. It took a long time because she also got involved in the Monash Motorsport program. So that's racing little Formula 3 cars. And originally they were ICE engines, and then they got into the electric engines and that sort of stuff. So she was, did that for about 3 or 4 years, was a head of development for certain, things.
Wow.
And I think I really promoted, even though it was meant she was taking so long to do it, I really promoted that because that hands-on stuff. And that really put it in really good stead when she did graduate, and she got a really great job. I won't talk about the company and that sort of stuff,
fair enough. But
she got a really great job, and for 3 years did the hard yards as a FIFO type worker.
Wow.
In the energy industry. And, had to sort of really deal with a lot of, a lot of stuff that, when you're in an office environment that you don't. Like she was with the tradies. And I tell you, they're straight shooters, all straight shooters. And if you do something stupid, they're going to let you know. And if they think it's because, they have some sort of perception about females or something, they'll let you know. So she had to, we had to, that nurturing part was not even about engineering. It's also nurturing is if you build resilience in your kids.
Absolutely.
And so, and I said to her, stick it out for 3 years. You've got to work a minimum 2 years at a company, I believe, right?
I agree.
Yeah. I agree. And she did, and now she's reaping the rewards, the dividends from
That's
that.
Fantastic.
Yeah, she's now working for another company, but she was basically headhunted. So yeah.
What was your first job out of uni?
Okay, so I was thrown in the deep end straight away, essentially, and I look back and I really appreciate that I was. So went into the rail industry. So the company I worked for made components for buses, the windows, and that sort of stuff. And they decided to start making train doors, but in an aerospace way with aluminium honeycomb, fully bonded.
Wow.
Aluminium.
Super light and strong.
Yeah. And I had worked at Ciba-Geigy developing the resin for honeycomb structures.
Right.
And so I went there, and my first job was to set up a whole manufacturing plant as a graduate.
Oh my gosh!
for to produce composite rail doors.
How old are you? Like 23?
Yeah, something like that.
Jeez.
Yeah. So I was thrown right in the deep end straight away, and as I said, I really appreciate it now that I was. And so baptism of fire. Had to go down to the aerospace companies down at Port Melbourne and, try to get in there and say, look, this is what I do, and do you mind helping me?
Wow.
All that sort of stuff. And anyway, we set up, and it was, so very successful. We started producing doors for not only Australia, but Hong Kong and other sort of places. And I ran it as like a manufacturing manager of that sort of plant, and then
wow, I can't. You must have got a bit of kick. What's the word? A bit of resistance from some of the older crew.
Absolutely, because
who is this young buck coming here telling us?
But they were right.
I didn't say that. Yeah, that's the thing. That's the thing. So that's interesting
because although they didn't know about all that composite side of things, and I was an expert in that, and then when I was sort of as a manufacturing engineer, when I was sort of trying to tell the tradies or the workshop people, the tool room blokes, for example, how to do a stamping press or mold for the sheets of the doors, for example. And I said, our press isn't big enough. We can't do it. There's too much force, And they would look at me and sort of say, why did you design it that way? Why didn't you design it with a shear cut, starting with a small cut and then shearing it? And I go, yeah, you're right. And this is sort of both humbling, but it's so very important to realize that as a young engineer, you really know shit, right? And you need to learn off all these sort of guys, especially people who actually are physical with the product they touch.
It's a really important point. I had this conversation with a rail manufacturer, and you've got all these engineers creating these rail feet and what have you, and then you've got the people actually installing them. And unless you've actually physically handled and gone, and actually installed something, you can't really, you don't know where the improvements actually lie. And it's like, a similar thing is like being an electrical engineer and electrician, who we have, I think, two up there who are both.
Yep.
The practical and the theoretical, which is a lovely combination.
No, absolutely. Yeah, this is what I said before. It's like we have electrical engineers, but they're not allowed to touch a switchboard, right?
Unless they're an A grade.
Exactly.
Yeah, that's the thing.
But that electrical engineer has to design the switchboard.
That's right. Yeah, I know.
It's a non-circular type sort of situation there. You need to make it social. I was in Germany. What brought this home? I was doing a exhibition in Renewables in Germany, into solar anyway. Yeah, and I was there with one of my colleagues, a young German engineer, and we were putting stand together, and he was about to wire up the LEDs and all that sort of stuff that we had on the stand. And I go, "What are you doing? Stop! You're not allowed to do that." And he goes, "Oh," he thought, "What's wrong?" And I go, "Oh, in Australia, we have to get an electrician to do that." And he looked at me and actually said, "Are you stupid?"
See, logically he's right though, isn't it?
Yeah.
That's the thing.
Well, that's what brought it home. That sort of, you need to, be able to sort of, at least connect, wires and play with it.
Absolutely.
To actually come up with better designs.
Yeah. That's really interesting point.
So
we have this conversation a bit with the electrical and electronic engineers, and we got mechanical up there as well. We talk about all of this, and it's a bit of a funny one. It's I don't know, and sort of it must be a money thing. I don't know. I don't know why it's like that. So you're designing this basically this factory, this manufacturing plant, and how long were you there for?
I was basically in the company, but it was we were owned by a New Zealand company, then we got taken over by a Swiss company, and then ultimately an Austrian company. So over that time period, it was probably about 11, 12 years.
Wow.
Yeah.
That's great.
Yeah.
That's enough. Yeah, that's someone who stays in the company long enough, they get to know stuff, don't they?
That's right.
You really get to know stuff.
Yeah, and that's what led me then to my next job, right? There was this was in the sort of days where China was just starting
the manufacturing
for globally, right?
Yeah.
And so there was a Chinese company that sort of headhunted my boss, and he then my boss sort of brought me on board. And it was basically doing what we were doing for the other three companies I worked for up to that time, but manufacturing in China. That was the big difference, right? So I then sort of did another 10 years for that company, but it was a lot of it was in the early days was going to China and develop factories again.
Yeah, wow.
To manufacture this sort of stuff. And working on the first, for example, what we call plug sliding doors, the ones that plug out and then slide along the body.
Yeah, right.
So
I know.
we developed the first type systems for in China for those, and supplied the first sort of Chinese trains with that sort of type of system, and the control systems and that sort of stuff as well. Making the composite doors there. That was a really interesting time. I mean, it's we look at China now, and it's sort of it does things so well now, right? But back then there was a whole bunch of quality questions and all that sort of stuff, and I can understand why. But I saw the progression of China from a very average manufacturing type. Low quality to a very high quality. I was in that transition phase.
I mean, contrary to what a lot of people believe, they actually spend a lot of money on developing that industry. Tool makers, die make, machinists. They're very good in that respect, aren't they?
Again, it's because they're manufacturing. They're now venting the new stuff. Like they're ahead on AI. They're ahead on quantum computing. It's not as if they're following anymore.
That's right.
It's because they've got these people that are doing stuff, right? You think about a product now and you think, I'm going to invent this, and you just quickly look at Alibaba and there's about 50 companies are making it. It's been quite amazing to have been involved in that sort of basically going there and in some of the states I went into, or some cities, basically seeing rickshaws taking people around to where it is now. It's incredible.
Korea seems to be doing a similar thing. Like they're definitely a tiger economy. 50 years ago, it was completely different, and they just went crazy with electronics, surpassed Japan. Yeah. Sony, Mitsubishi, all those companies sort of got a little bit left behind.
Yeah.
Samsung went crazy. I mean, huge companies. They are gigantic.
LG,
it's 4 or 5 companies own Korea, as opposed to, say, Taiwan, where there's a lot of smaller companies. But they're doing some amazing stuff.
Yeah.
And in energy storage, they do a bit as well, don't they?
Yeah, they do. Unfortunately, for some reason, the industry hasn't really taken off there, but they actually create a lot in our space.
Right. Yeah. Why do you think that is?
Possibly the subsidies, possibly the energy mix they have already is different to ours. Right. I think they have nuclear and all that sort of stuff.
They have nuclear, They burn rubbish as well, apparently. High temperature incineration.
So maybe land is more value. There's a whole bunch of things.
You're dead right, because Korea is a very mountainous country, not much agricultural land, compared to, say, Japan. So that has really tempered their approach. I have a bit of an interest in Korea. Married to one. So my wife's South Korean, so I sort of looked into it quite a bit. Now, so I reckon, because you're my age, you've had a few jobs, but then again, probably not that many, because you've stayed in these jobs for a fair amount of time.
Yeah, I'm very loyal.
Yeah,
and I think that's what we're losing also.
Totally. I want to ask you about that. Yeah.
So, like even now with Jamie, the amount of respect I have for him, taking me on and, us going on this sort of journey, everything, there's no behind the back stuff. It's like, I tell him straight, this is what I want to do, mate. And he's totally supportive and that sort of stuff. So, the thing is, if I start getting itchy feet in a company, they've always spoken to me and sort of said, okay, what do you want to do? And that sort of stuff. And they've always used it as a platform to stay within the company. I think, as long as you're, a lot of people have the grass is greener type thing, and as long as you've got a reasonable amount of happiness.
And whatever happiness means. But to me, it seems like you need to be intellectually stimulated every bloody day.
Yep.
That makes sense.
Yeah. And that's why I enjoy a startup environment. And that's what I really have done. Like just about all the companies I've been in has been a startup. 75% success rate. The other way, usually it's the other way around.
That's really good. Yes.
Yeah. Evo Power's probably been. I owned a solar company prior as well, and we haven't got into my solar days yet. No. Oh, let's go to your solar days. What was the company? Okay, so I was in rail, right, and the first IPCC meeting happened and all that stuff with all the scientist reports and all that sort of stuff. And prior to that, already I lived near the beach and all my life, and being a very observant thing of not only people but everything around me. Yeah, it's all data for me, right? Yeah. and so I saw something happening to our environment. I could feel it.
Yeah.
I just didn't, the stuff wasn't there yet. We were early days of talking about it. And so the first IPCC meeting happened, etc., with all the scientists, etc. And they came out with their reports, and I sort of read it and that sort of stuff. And I said, you know what, I want to pivot, all right? So back then, if you imagine 2005, 2006, there was basically mum and dad electrician companies that were doing solar installs for, they'd been doing it maybe for off-grid or
yes,
and started getting into sort of, grid connected sort of stuff. Because the solar panels was just so expensive. We're talking, $3.50 a watt when I first started, at least.
2003, I started at $10 a watt.
Yeah,
so I know,
okay. Yeah.
And when Craig was on, he was talking in '98. He said they were $20 a watt.
So, but there was all these incentives around that time. So what happened was that I had all this deep project / engineering / commercial experience through the rail industry. And what happened was some other people in the rail industries approached me and so they said, look, we're starting this company in Queensland. It was called Ecokinetics. And, we want to get into the renewables. And I sort of said, okay, I will too. I do too. And the company I was with, the Chinese company I was with, I approached them and so I said, look, why don't we sort of give this a go? And anyway, so at that particular time, there was a bunch of group buys with councils at that time, because the idea was this: if the council's ideas were, if we could organise a mass purchase, like group purchase, then we can get the price down for people, right? And the mum and dad electrician type couldn't deal with all the regulatory sort of stuff, putting together a tender and all those sort of things, and so we became specialised in offering project services at that early level, which was basically projects were houses, right?
Yeah, wow, of course.
And so we won. I won my first tender with Manningham Council, and I approached the Chinese owner and so I said, "Oh, looks like this is a goer." And he said, "Oh, okay. Oh, I don't really want to do it now. I want you to concentrate in rail." And I had just gone out there,
done all this work.
Yeah, exactly right. Anyway, so I spoke to the guys in Queensland and sort of said, okay, this is the situation, because I was representing them in the end of the day, right? And they said, why don't you start up Ecokinetics in Victoria? And I said, yeah, I'll do that. So I decided to start the company up, and so we were extremely successful over 3 years. We had went from 7 million in my first year to 12 to 40 sort of million sort of thing. So very quick growth. It was at the time also of the $8,000 rebate and all that sort of stuff. So, and then we got bought over by a publicly listed company called CBD Energy, which we won't go into too much.
I won't say a word, but I don't know. I haven't. There's nothing rings a bell, but I won't say a word.
Yeah, okay. But anyway, it's so we sold out, but I was still working for them, and it was good. That's where I first started getting my experience into the larger projects as well. We did a project in Thailand, for example. Our first one, it was an 8 megawatt, but that was their first solar project over there. I scoped projects out in Germany and Italy and that sort of stuff for the earlier sort of assessments, etc. Of those. And so it's where I started more into the larger, utility sort of space. What I realized is that's a sort of area that I really enjoy. It's the larger projects. And so,
what more challenging, more moving parts, more.
Okay,
Yeah.
the reason why I wanted to swap in the first place was because I always had a very cushy position in the rail industry by 20 years in, right? I had my customers; they trusted me. They would just give me the orders. You know what I mean? It was a very comfortable position to be, to then say, I want to start on this totally new journey.
Yeah.
That's unknown. No one else is doing it. But the reason why I did it is because of what I earlier said about that. I did believe climate change was a thing, even though it was very early. I mean, a lot of people weren't into the whole climate change is real sort of thing. And so I thought to myself, and I go, I got kids, I'm going to have grandchildren, and one day they're going to say, okay, were you part of the problem or were you part of the solution? Yeah. And that's why I pivoted. That was the main reason. And so, but because I mainly dealt with in the, we're talking rail contracts here. So we're talking, high level technical commercial negotiations and that sort of stuff. Because I came from the environment, I yearned that a little bit in the renewables. And so when utilities were there, that's what I
That makes sense.
doing.
Yeah. See, there's a lot of moving parts. There's that makes sense. Attention to detail. Yeah, I can see that.
Yeah. Then when things went sort of astray with CBD energy, I didn't want to have my name attached to it. So I decided, no, I'm going to resign, and decided, you know what, I'll have a little bit of a semi-retirement sort of thing, and this was in my 40s.
Oh, too early.
And so I started my own because I had worked in China for. I had a lot of contacts, and I was a manufacturing engineer. So I did I made a company that was able to source things from China. It was like a China procurement sort of thing, So, but it meant that I was only sort of working 2 days a week, and the other 3 days a week is where I was driving myself nuts.
Yeah.
So that's when I realized that no, I've got to work the rest of my life for 5 days a week.
Well, you know what they say, when a man reaches retirement age, after he retires in the next 5 years, the death rate is huge because there's not everyone, but it's statistically shown that it's you got to do.
I've read that. Yeah,
you got to do something.
Yeah.
You're not designed. There's a myth that you're happiest when you're on holidays doing nothing. It's a total myth. You're happiest when you're feeling productive and loved and you're deeply focused on a thing that you really want to do.
Yeah.
That's what they say.
And hence you can connect the dot now with the shooting, right?
Oh, totally.
Because I realized I needed something like that.
So that's when you start. Yeah, right.
Yeah.
All right, let's jump to because there's so much we haven't even scraped the surface of Evo Power. So that Evo Power came into existence 4, 5 years, 6 years ago?
About 2019, in the middle of COVID, or start of COVID.
Wow. That must have been a hard time to start to be involved with a startup business.
Yes and no. It gave us time to do things properly. We could sort of slow things down a little bit because we didn't. Everything had slowed down anyway, right? But it allowed us to sort of, do the designs, do the testing of our product. Back then, it was the first product was like a 60 kilowatt hour, 15 kilowatt sort of little CNI sort of system. It could, it was using Mechatronics sort of inverters and that sort of stuff, so we could do, UPS backup sort of style. So it was, but we had to sort of, back then the AS 5139 standard came out and we had to make sure it was all designed to that. We did testing, thermal testing, because we were putting those things in an enclosure and they produce a lot of heat. So it allowed us to do all that. And, it was just basically Jamie and I, on the CAD machines and that sort of stuff, putting all these, going out to manufacturers, getting getting things made and all that. And setting up the factory and, getting our first employees. We got a graduate, and we also got an electrician to work on the floor to put them all together. So the early days, was really hands-on. It was like we were involved in everything, There was no real defined role. I was like general manager, but I was engineering. I was designer.
Wow.
I was, sweeping the floors in the factory. I was forklifting things in and out. Well, it was like, okay, it's a startup.
That's what you do. You got to do those
exactly,
things,
right?
Yeah.
So that were the early days, and we got good traction, and I think to Jamie's credit, so he worked with LG Chem, and he realised that there was a segment of of the industry that wasn't really being catered by from Tesla. They were interested more in the larger stuff.
That's right.
The utilities, etc. They had their power wall, but the C&I space was
that middle space.
Yeah, exactly. Yeah. So that's where we sort of, we started speaking to CATL, Cattle, and we became their first customer, the first Eneron rack.
And they're a huge company, aren't they?
Yeah, yes, correct. They're the number one.
Yeah.
I mean, if you look how big battery space is now, they're the number one in the world. So, that's huge. But we were in Australia. That was the first Eneron rack units were delivered to us in Australia.
Wow.
Globally.
Wow.
Yeah. So we we very quickly started becoming the experts. We were sort of, looking at the cattle product and sort of saying, look, there's some deficiency. We were working with them quite well and have a very close relationship with cattle.
And this is the lithium iron phosphate solution, isn't it?
Correct.
Yeah,
yes.
for the people listening, that the safest lithium chemistry available.
Correct. And they had sort of some good safety systems in there because back then there was a lot of questions around safety, the fire sort of stuff, and that was mainly because of the NMC batteries. When they did catch, they would just keep on going.
The cobalt.
Yes, LFP is a bit different, and again with my data thing, I almost researched every fire that's happened around the world and tried to sort of work out what's actually happened.
Wow.
I mean,
that makes sense. Yeah, wow.
And so in that, I'd sort of understand the chemistry. I understand the mechanisms because I fortunately I get you guys get, for example, the N certificate. I get to sort of see all the results.
I bet.
So understanding that all the mechanisms that happens was really, really important to me, and from a safety point of view. But so they had their own aerosol. They had the fire and smoke detectors and that sort of stuff. Now we've moved on a little bit more. We've got the American standard NFPA 855 came out about a couple of years ago now. And now the batteries are even more advanced. They've got sort of deflagration panels.
Okay, what does that mean?
Okay, so what happens? So these enclosures are like IP66, right?
Yep.
So they basically can go underwater. So what happens in a fire situation? You've got a lot of gases being released, and that causes pressure internally. Mm-hmm. Now, one of the biggest dangers of the gases is when they concentrate, and so you got a lot of gases being released, not in an enclosure, but not being released out to the environment, right. And so the concentration is very high, right. And you've got the whole thermal runaway happening.
Yes,
it's going to go boom.
Yep.
Okay, so the deflagration panel actually sort of at a certain amount of pressure, very very small pressure difference, actually explodes open and allows the gases to vent.
Oh, into the environment.
Into the environment,
right,
which then sort of decreases the volatility by a
because
long,
it's decreasing the concentration, hence the volatility.
Correct.
Yes.
And also, for example, there's also that's NFPA 68. The NFPA 69, which is part of the main standard, is also about gas detection and then active venting. So there's two different systems that you can have. You can have one or the other, but if we look at the new batteries that we're supplying now, they have both.
I was going to say, why wouldn't you have both? Yeah.
Yeah, it's sort of, they're both doing the same thing.
Right.
In essence.
Sort of plan B, isn't it, really?
Yeah, exactly. Yeah, so it's a bit of redundancy there, right?
That's good.
But with that sort of NFPA 69, that's all about hydrogen detection at a certain level, once it gets to a certain level, and then assuming that, we're reaching a volatile level here, and basically a fan activates and opens up a flap, and just, again, it's vents it out. And then it's got its own UPS that can go for 2 hours as well. So, yeah.
Yeah,
so,
right. Wow.
Yeah.
So I know a lot of the old, correct me if I'm wrong, a lot of the, I thought older systems, or maybe they use them now, have like a powdered glass that explodes. Is that still a system being used?
It still happens. So the idea in that is that if you can stop the gases catching fire,
yes,
then you don't have fire.
Yes.
You have heat. That's it.
Yes.
Okay. So so the idea was that if the heat detector has rises to a certain temperature level, and smoke detection, so the two have to happen at the same time.
Right.
Then it releases the aerosol.
Right.
And that disperses the oxygen, and if there is an active fire, it will put it out. And then you're only dealing with heat, and as long as your other systems are stopping the volatility of the gas mixture or concentration of,
yes.
then you only have to deal with heat. It's a chemical reaction, so you're not going to put the heat out. You just got to let it go, but at least you've got a controlled situation.
Yeah. I understand.
Yeah.
Wow, there's a lot to it, isn't there?
There is a massive amount, and then it's also like I see subsystems come out like sniffer systems and all that that detect the presence of gases and and sort of, I'm not going to mention names, but the best way to detect is through a good BMS. Okay. So within, like, gas detection happens probably about 57 minutes thereabouts, right? Because it's broken the seal on the battery packs. It's a plastic, so enough heat builds up, deforms.
It's a sacrificial seal, isn't it?
Yeah, exactly right. So, but the best measure is the BMS measuring the sort of temperature of the cells. And that happens only after 12 minutes into thermal runaway. It's a much earlier way to detect it. And so, I suppose that if you're a customer, what I'd be doing is reading those APIs, and once they get to a certain level, assume that there's a fire. Not waiting for the fire control panel to go off, because that's going to probably go off a lot later.
That makes sense.
Yeah. So so there's little nuances like that we've sort of realized at Evo Power, and I try to sort of talk to customers on a very logical level in that sort of sense.
Is that something that they respond to? Like,
oh, absolutely.
Do they understand? Obviously, safety is incredibly important, but do they understand those key differences, say, between what Evo Power are offering and, say, another company? Do they understand that? Okay,
that's a very good point. You've got different customers. You've got developers, you got your retailers, and you got your distributors. Yeah. So at the developer level, they understand it, but price is the most important thing.
I knew you were going to say that. Yeah, okay.
At the retail level, there's a 50-50 split.
Right.
At the DNSP level.
Oh, yeah, safety first.
Yeah.
Always.
So we find that we get a lot of DNSP work because one of the things is our knowledge that we can pass on and help them out. And the other thing is that it's such a regulatory environment. which makes us better.
Yes.
Right. So when we look at some of the experiences we've had, it's like being in hell for a couple of years with dealing with DNSP, but the learnings you get and how much more professional you get in your product and your engineering and your what you do with the integration piece, because the integration piece is the big thing. I think one of the most important things, because the integration piece is what sort of, if you like, it's what makes the big difference, I think, is because you get a customer and you sort of see a problem or an area where you can improve efficiency, and we can get into that if you like. But when you've got a standard integration and, that doesn't necessarily involve a integrator, right? Then you just have to sort of, suck it up, princess. You know what I mean? But with us as we're primarily an integrator, not a battery supplier.
Gotcha.
We do design BESS systems, but our primary focus is the integration piece, right? And so at EvoPower, what that allows us to do is, if you want to, play Jimmy Barnes, song at a certain time, we can make it happen. But I'm being sort of flippant there. But what
Just
allows us, what allows us to do is it basically is we notice things or deficiencies in the BMS and batteries, for example, and in our code we can sort of drive more performance out of the batteries and that sort of stuff also. Okay, so it's something that So
the key is the algorithm.
Yes, exactly. So where that's valued is at the DNSP value.
Right.
It's also valued at the developer level because ultimately, that's they're trying to make money out of the system.
Absolutely.
And so, at the developer level, it's really, really important to maximize all those kilowatt hours, all the out of the batteries, and get the most out of them. Again, from a EvoPower perspective, what's been great is dealing with the likes of Energy Queensland and Ausgrid and a bunch of these other guys that we do deal with, Sappin, etc.
You haven't mentioned any Victorian distributors.
Yeah, AusNet. Okay, there you go. Good. It sort of makes you better. It's they have an engineer for everything. They've got the engineer for the paper clips. You set the paperwork you send through. So you're dealing with a lot of different sort of experts from their side, and so you got to keep all those guys happy and humming now, because they report back to ultimately the guy who's in charge, and and if they're not happy, then so it as I said, what it's actually done is made us really sort of streamline and a lot better. Our algorithms now in our energy management systems cater for deficiencies in BMS, caters for problems that avoids problems that could occur if the wrong charge discharge signals are given, all those sort of things. And having 3 or 4 years, I mean, in a very early industry as far as experience, right, means that you're actually picking up a lot of issues. And then some of those issues, it's an interesting, depending on the type of customer. Some of the issues that certain type of customers sort of say, well, you're treating us like guinea pigs, right? And it's true, but it's the state of the industry we're in. It's yes, we're all guinea pigs to a certain degree.
Exactly.
But the last 3 years, as far as putting a lot of systems out there, and having a lot of different problems. I mean, we're talking, EMS problems. We're talking about especially communications is a huge thing. Common mode voltage. Didn't even know what that was.
I still don't know what it is.
Yeah, but it affects sensors essentially. It's basically little AC signals which are coming back up the wires. Like a sensor is trying to give a 0 to 5 volt or something, and then you got a signal, a voltage coming up, which is then telling you your, for example, a piece of equipment is at 500 degrees Celsius, and you know it's at 50.
How important a response? It seems to me when I'm listening to you that response times is incredibly important.
Yeah.
Is that? Can you expand a little bit on that?
Response time as far as servicing?
Response times in regards to these processes. That a signal is sent to say this, and then the response comes back like that.
Yeah. So this is...
or am I on the wrong track?
No, you're on the right track, yeah. And this is the key difference now from the solar industry, which I was part of, obviously, to the battery industry. Okay, so with solar, you essentially got sun shines, produce electrons, inverter, generate, right? It's an uncontrolled process. You don't really. The only thing you can do is to say, we've got too much energy in the grid, curtail, right? So with batteries, it's totally a live system. All right, it's an interactive live system that's available, that is able to make changes instantaneously within milliseconds, go from 0 to 100% power, or go the other way as well. So all those sort of things, that sort of response time, as you were saying, is critical. So what's happening is there's a lot of stresses on the system because we're, again with solar, you may start at 20%, 30%, and it goes up to the peak and then comes down and that sort of stuff. But it's very fluid. With PCSs, which is battery inverters, we call them PCSs, power conditioning systems, because it's to call them inverters is a little bit sort of derogatory to them. Well, power conditioning systems is like, okay, we're seeing what you're doing, Mr. Grid, but we can help you, right?
Hang on, are we about to talk about grid following and grid forming?
Well, we can get there.
Yeah, good.
But I'm more talking about all those sort of control elements. Right. So the amount of feedback loops that we're getting as well, from an integration point of view. I mean, we're monitoring at any given time 600 alarm APIs at any given time. 600, yeah. Now, it's up to the customer of whether he wants all 600 or whether he wants 50 or 100, but he can link to all of those, right?
Wow.
And that's just alarms. Then it's all the sort of BMS data, what are all the cells doing? And, it's an incredible amount of data.
But that's a lot of combinations of information, isn't it?
Oh, absolutely. Our warranty files are just huge. Every day they could be a gigabyte file.
Oh, my gosh.
So this is the amount of data we have, and it's quite interesting. When we're talking about and then the speeds of things. Like for example, with with very fast FCAS, right? You've got to react within 1 second, and follow a droop curve and all that sort of stuff at the same time. Then you've got your control algorithm. You don't want to. You can't overshoot too much. You can't undershoot. You've got to hit the target. So then there's all these control algorithms. The complexity is just immense.
And imagine if a system was designed to actually do FCAS and arbitrage. How the hell do you work that bloody mix out?
Exactly. So fortunately, it's usually one or the other because it's sort of
too hard to do both. I'd say.
Well, it's when you've got an FCAS event, it's probably more money. That's the thing.
Yeah, but it seems that recently people are moving away from the FCAS to more arbitrage because FCAS doesn't seem to be making the money it used to. Or is that?
Well, it's quite an interesting thing, and without mentioning companies again, it's
well, we'll have to give you a special word to use when you say that.
So we've sort of probably on the Dual sort of system, we've sort of probably registered the most 1 second FCAS CNI systems in Australia, right?
Wow.
Now, through that, we're sort of seeing, your aggregator is very important to choose. And we're sort of seeing some aggregators that just on the FCAS market alone are getting 4-year paybacks, for example. Yeah, so that's just on FCAS. Yeah, so yeah, it's
that's pretty low.
and that's their, I don't know how they do it, what their algorithms are, but
right, that'd be secret, I bet.
I think it's worthwhile. Look, the way I see, I hear things, and again, I've got this analytical data fed mind, and I now hear things that the FCAS market is going down, but then it's counterintuitive. We're getting more and more electric vehicles. People are plugging. Okay, they've not got the AC on now. The people are plugging in the electric cars when they come back home. It's causing the same sort of spikes.
It's interesting too because you're throwing AI. I did a LinkedIn.
Thank you.
LinkedIn
I was going
post
to get there
for a while ago that said about
data
AI
centers.
more so AI manipulating this market. AI talking to AI in regards to these big batteries and artificially keeping the price up, and that was more for arbitrage. But data centers, that's another thing. Yes, it's
so that's growing. So I think FCAS will be around for a while until we can stabilize, until everyone's car's electric, until until we decide on what our, for example, base load's what's going to supply our base load. Do
you think that's why the distributors are? Got to be careful here. Do you think that's why the distributors are more than happy to encourage VPPs on a domestic side of things, because they really don't have to put any money fixing up their decaying infrastructure?
Yeah.
Please no. Well, I mean that's my thoughts anyway.
You know what? That's most of our business now is exactly to avoid upgrading infrastructure. That's our business model.
It makes sense. Yeah.
Because a lot of our distribution company customers are all about putting batteries at substations.
Yes.
So and you got a growing town, for example, that substation.
What are you doing?
So they're throwing in batteries because it's less expensive than upgrading the infrastructure.
They've done their cost benefit analysis.
Exactly. So
it makes perfect sense.
Yeah, and that's where it's sort of I think the future. I'm hearing a lot more now that AEMO are actively sort of saying to solar and wind developers, you need to have batteries in conjunction when you're doing the development.
I was going to ask you about the wind side of things.
Yeah.
Because it seems to me that when production gets curtailed on these wind farms a heck of a lot more than the solar farms, and they are a bloody prime candidate for storage.
It's quite interesting at the moment. There's very little solar and batteries, and very little wind and batteries that we're involved in. Everything is on its own. The battery farm as such on Arbitrage and FCAS is a business model. It doesn't need to be connected directly to solar because they are a market participant. It's got access to the market, the negative price signals and that sort of stuff. Is it cheaper to have your own solar plant that's, let's say, 5 to 6 cents a kilowatt and feed the battery, or is it cheaper to buy it at 3 cents or zero from the market?
Well, when you talk about 4-year payback, both the solar from a business perspective.
Yeah.
Because it is all still speculative, isn't it, based on the changing rates of energy?
Well,
and that's just how it is.
Yeah.
Because energy does change in price.
Exactly. And what's interesting, like when you're trying to sort of justify the financial side of a battery, it's mainly always decided on arbitrage because it's a market mechanism. FCAS is like, I suppose hit and miss. But the beauty about FCAS is that you get paid whether you
use it or not. Yeah, you pay for it being there.
Yeah,
whether it's used or not.
Correct, and then you can get a double take because you're already getting paid for energy that you haven't released.
Yes.
And then you can do arbitrage still because you got that energy.
That's what I was, that combination.
Yeah.
Now, let's get to nitty gritty with Evo Power. You've got a range of products. Can you sort of go through the products that are currently available now and maybe we won't talk about what's coming. There's always something new coming. Let's talk about what you got now and what space it sort of fits into.
Sure, I'll tell you what's coming up as well because that excites me also. Okay, so we've got our CNI solutions, and we started with what was called our Neo, and that was using Delta inverters, 100 kilowatt inverters, and we could master slave them, although there's different words for that now. And so up to sort of 1 megawatt. So 10, we could put 10 units together. They act as one as such.
1 megawatt hour?
No, 1 megawatt power.
Deliverable.
Yeah. So we can go up to that. So we have up to a year or 2 years ago, we could only put 5 together, and now we can put 10 together. So there was more development on Delta side. And so now we originally had from 100 kilowatt to a 500 kilowatt Neo systems, and now we've got 600, 700, 800, and a megawatt. Yeah. And they're commercial and industrial, so it's a decent size, right? And then we can parallel as well. Yeah. So and then more recently the all-in-one type, because that dealt with like a power skid. Let's say up to 500 kilowatts, and then we had to have separate battery racks. And now we've got our Flex solution in that CNI space. And that is all based around having the PCS and batteries all in one rack. Sorry, I'm Italian here, so
no. Go for it, please.
So, and that also can go up to 1 megawatt as well. So we can put 10 of these together, and we throw in a combiner box so we can put on the MCCBs and switch gear there. So now the PCSs and the batteries in a 100 kilowatt, 205 kilowatt hour block, and like a half C battery. And we can just sort of add more if you want.
Explain to the people, like there's a lot of people listening who will be technical. There's a lot of people who are less technical, especially when it comes to batteries. So when you start talking about C, we are talking about the discharge rate of the battery. Can you explain the difference between, say, something that's 5C or 0.5 C? Just a quick summary.
Yeah, sure. So 0.5 C essentially means that you can only discharge it at half its capacity. So let's take the Flex, for example. So it's 205 kilowatt hours. You can only do half C, which means you can do approximately 100 kilowatts of power. All right. And that also half C translates to a 2-hour battery, because 100 kilowatts, 205 kilowatt hours times 2 times 100 gives you 2 hours, and you got that. That's the C rating, and 1C is basically power rating versus energy is the same. So in the exactly the same case, you would have a 200 kilowatt PCS with 200 kilowatt hour, and that's called 1C or 1 hour battery. Yeah. So we're sort of noticing a trend now, just to sort of, and then you have sort of 0.25C, which is a 4-hour battery, and then we're also starting to talk about an 8-hour battery, and it gets ridiculous to say 0.125.
But it's funny because when I started, doing this many years ago, batteries looked like off-grid C100, C10, but it seems like they've changed. Because C100 was discharging the battery over 100 hours. C10 was over 10 hours. But now they seem to have turned it around a little bit.
It's the other way,
Yeah.
Well, back in my hobby days, the C rating, you had C10, C30s and that sort of stuff. But that was like, you could get 30 times the amount of power of the energy capacity, right? But the reason why we stick into the 0.5C mainly and that sort of stuff is for the longevity.
Yes, I was going to say that, yes.
The harder you push the batteries, the more their chemical structure is going to break down.
Because chemical reactions happen at a certain speed. And that's the thing that people don't understand with batteries. Go, why can't you make it discharge? No, because this reaction happens at this speed. You can't speed it up.
Yep. So that's what people wanting 15-year, 20-year warranties and guarantees and that sort of stuff.
They really want that?
Yes, that's...
okay, I thought it was 10 years, so they want more now.
Yeah. So we got to 10 years a standard, which is pretty high, right? But
it is.
A lot of people go for the 15 and 20-year options, yeah. So we got this LFP that we need to sort of make last that long, and that's the slower... The harder you push the accelerator on them, the more they burn, right? So it was interesting to actually find out like a half C battery was actually the same as a 1C battery, the same cell.
Oh.
And all they do then is sort of say, no, you can't have 15 years on the 1C, you can have 10, right? Because it pushes it harder.
Right.
Yeah. So... we didn't realise that until we sort of open a couple of...
and had a jolly good look. Wow.
Yeah.
Because there's a bit of a black art with these, the people who make these batteries, these alchemists, I don't know, Order of the Golden Dawn, whoever they are involved in. It's science and something else is going on a little bit, isn't it?
Yeah, absolutely it is. And I think we're just getting so good with the chemistry nowadays. Especially with our LFP, it's pretty much a well-developed sort of resource, if you like, a battery resource. And we know what's going to happen to it. We've had we've had batteries out there for a long, long time now. We've had even Tesla cars. We keep getting data on that. There's cars out there with millions of kilometers, right? Already. So we're starting to understand how it degrades, and one of the big things is the actual degradation rates from the OEMs are very conservative. So where they're sort of saying that we'll reach 80% after 15 years, let's say, what we're actually realizing that you could still be at 88%.
Wow.
So they're conservative because obviously there's money tied to the penalties of those. So, but we're finding that things are lasting or doing a lot better than.
Interesting.
Yes, and because we're getting the data now, we've got all the warranty files for the last 7 years.
That's very interesting because like if you sell a Tesla second hand, you get bugger all because everyone's worried about the battery. But maybe there's more battery energy in that battery than people think.
Just have a look at the state of health. Exactly.
That's a really interesting point.
Yeah.
Now, this is what I really want to hear. Well, I want to hear all of it, but the whole grid forming, grid following, can you explain what those terms mean and how Evo Power is involved in developing products specifically to suit this? And what does it all mean?
Great question.
Thank you.
Okay. I think there's a lot of misconception out there about what grid forming actually is. Grid forming, even by its name, implies that when there is no grid, it will form a grid and supply whatever a section of the grid. Let's just say I can't do the whole grid because you're dealing with small pieces of equipment. But so in essence, there's different grid forming types, and this is where I'm coming from. So you can have a grid following PCS that is in grid forming mode. Yeah.
I'm digesting. Continue, please.
Okay, so let's say you're in grid. You're in grid following.
Yeah.
And as I said earlier, batteries are very dynamic. So they're getting market signals, power and PQ commands coming for back and forth all the time, and they're in grid following mode, right? Then you go, you know what? The grid is really struggling at the moment, and there's a market mechanism to support the grid, right? And then you go into grid following, grid forming mode. Okay. So in grid forming mode, it goes away from the PQ command. You no longer send in.
Please explain PQ command.
Okay, so your power and power factor, basically the reactive power and power. Yeah. So
I didn't mean to sound like Pauline Hanson when I said please explain. But no, okay.
So yeah, that's the charge and discharge signals.
Okay.
And then basically when you go to grid forming mode, what you're doing is something different. You're sending voltage and frequency commands. You're no longer doing power and reactive power. So the voltage and frequency commands are all about the stabilization of the grid. So it's a really grid supporting mechanism, and it can be done automatically. You don't have to send commands. So it can be trying to fix the voltage or trying to fix the frequency by itself.
Yep.
Yeah. So that's called grid connected grid forming. So it's the grid forming part of it is that it's actually trying to correct the grid. In essence, it is trying to set the voltage and frequency.
So this is what FCAS is effectively doing.
Yes and no.
Oh no, I thought I got it.
So FCAS is still doing power. It's all based on discharge or so. In essence, an FCAS is like is we know we're going to have an issue in 5 minutes, right? Turn on FCAS mode, and then as soon as you see the frequency drop or go up, charge or discharge.
Yep.
Okay, at a certain droop curve. That's FCAS.
Yep.
Now, and then you got 1 second reaction time, 60 second, 5 minute, etc. You've got all the different markets there.
Right.
This is a little bit different in that this probably doesn't benefit a market player. It benefits a distributor, the grid forming, right? Because in the end of the day, if you sort of say, I've got a weak grid here, I want this battery continuously fixing my voltage and frequency.
Right.
Continuously. It's still charging and discharging and doing so, but it's trying to get to a set voltage point, whereas we don't ever try to do that in
FCAS.
In FCAS, yeah, exactly. Yeah.
And what is that worth to the distributor, that ability to grid form? Is that valuable to how valuable is it to them?
All right, let's talk about that value. So grid stability, I mean, the distributor needs to try to stay within certain bandwidths of voltage and frequency, and it's penalised if it doesn't.
That's the financial incentive not to do this. Yes.
Exactly. So, in the end of the day, it's basically about stabilising the grid, and that's what batteries are really great for, right? And this is something maybe I'm not sure if we have time we can talk about later, but what the future of our grid looks like, right? Because there's a lot of problems I think we have in trying to phase out coal and for that base load. But anyway, we'll talk about that maybe later. But okay, so that's from a point of view of grid following, grid forming combination. Okay, now what everyone thinks grid forming is what's called black start grid forming. So this is where, especially in places like Victoria, in Australia, where we have a lot of possible fire, etc., and grid lines are going down.
Malakuta, oof.
Yeah, so this is where you can actually, in the substation again, that supplies a particular town.
Yep.
It can be monitoring the main grid, and when it goes down, it can go. It is don't forget it's an AS4777 type thing, so it has to stop. But you send a signal like a microgrid controller could be there, for example. It sends a signal to go into grid forming black start mode, and it then I'll talk about the systems for black starting. It then sort of powers up the BESS again, and then the BESS tries to energize the whole town network. So just imagine what it's trying to do here, which is different to normal. For milliseconds, we're energizing a whole bunch of transformers on that network. So we're getting inrush currents of 6 times more than what,
Huge currents.
Yeah, exactly right. So this is what is happening at that time. So it then sort of stabilizes and forms the grid. It's basically setting the voltage and frequency for the grid, and then every other device down the track is following your BESS.
Yeah, right.
And so what that allows you to do, it allows you to sort of, you've lost the grid, you can power up the whole network in that sort of, I reckon there's a few DERMS things that will probably happen, like large loads and that sort of stuff will be disconnected because you want to get the maximum you can out of the BESS. But it can power up the whole town again.
Wow.
Basically. And then you can have gensets as well. Because again, we might only have a 2-hour battery, right? Then you can start your gensets as well.
Allow them to come up to operating speed and shift to and load them up. Yeah,
exactly. But in this case, they're also following what the BESS.
Yeah, of course, because they're following the BESS.
Yeah. So then, in normal terms, they actually form the grid as such.
I could definitely do some research because I've heard the terms and never had the courage to ask anyone exactly what they meant. Yeah. And I'm sorry I did because I reckon I've got 60-70%. I'll work it out. Yeah, it's wow. My head's swirling at the moment. Wow.
But okay, let's have a look at the equipment required, and that's what no one really knows, right? So you need a UPS that not only now is supplying UPS power to the control circuits, but then you've got all the air conditioning circuits and all that. So your UPS becomes huge. It needs to be 100, 200 kilowatt UPS. It
has to control the HVAC, doesn't it?
Yeah, exactly. So it needs to allow for it at least. There's tricks around that, which I won't get into. That's IP that we can keep.
No, you keep. No, right.
And then you've lost your grid, so you've lost your earth as such. So you need to have a earthing transformer that takes over that function because we're on 3 wires coming out of the PCS, right? So then you need your earthing transformer. You then imagine you've got like a protection relay at your RMU level. What's that doing? Monitoring voltage, frequency, and that sort of stuff. Current on your grid, and then shutting off your whole system. Well, you've got to do something to tackle that because all of a sudden you've got 6 times the amount of amps. You've got voltage, which is going way out of the spec of the protection relays. You know what I mean? It's a very complex. A lot of stuff's going on in that sort of black start sort of environment, and a lot of systems that you have to think about. Sorry to blow your mind.
No, I'm having trouble, but it's good. It's good because it gives me something to do some research on, so I understand. Wow.
And then even like email still catching up on the modeling part of that. It's if you look at the modeling on black starting, it just to say, just follow what the OEM says. But there's no sort of real direction for people.
So this is really new stuff. This is new.
Totally new. And we're working on one project which we hope to get up and running by June this year, and testing in black start grid forming sort of mode. So I won't go into where that is and all that, but
next time you come on, after you've done that, we'll talk more.
Yeah. If I don't come, it was a fail.
Oh no, still come. Look, we can obviously talk until the cows come home. Yeah. I have to admit, my brain is sort of pulsing in areas it doesn't usually pulse in because of I'm just trying to work some things out in my head.
Yeah,
I had a thoroughly fantastic time, and hopefully you have as well.
No, that was great. And look, I relish this opportunity because I think, I want to get stuff out there that I've learned. Yeah, and thank you for the opportunity too, Valley.
No, look, it's fantastic. Thanks so much for coming back in. An absolute pleasure. I look forward to our next meeting. We've scratched the surface.
Yeah, we really only have, yeah.
Now, if anyone wants to get in touch with Evo, what's the best way? Go to the website? What's the...
Yeah, go to the website. The traditional channels there of putting in a request on a form, and someone will get back to you. We've got about 6 or 7 salespeople across the country and all that sort of stuff. So, and if they just want to have a chat with me, that's fine too.
That's great. Thanks very much.
Fire, if they're concerned about fire, just knowledge, I'm happy to share.
Excellent. Thanks very much, Richard, for coming along.
No worries. Thank you very much. Cheers.
That was great.